Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's a problem for today for exam LTAM, long-term actuarial models. Kevin, age X, just started a new job at NED Industries. Kevin intends to work for this firm for the next 3 years and will look for new opportunities in the 4th year. Kevin uses the following 4-state model. Working at NED is state 0, and then the other 3 states are getting fired, state 1, leaving for firm A, state 2, leaving for firm B, state 3. Note that there is no such thing as return to state 0. You either stay in state 0 or leave it, no return. You are given also that the force of transition from state 0 to state 1 is 0.01 for any time between 0 and 4. The force of transition from state 0 to state 2 is 0 for the first 3 years. So this transition can't happen for the first 3 years, and then it's 0.12 in the 4th year, and then force of transition from state 0 to state 3 is 0 for the first 3 years, and then 8% or 0.08 between times 3 and 4. Calculate the probability that Kevin will still be working for NED at the end of 4 years. And you have 5 answer choices. So here's the solution. For the first 3 years, the only possible thing that can happen is Kevin can transition to state 1. Just as a reminder, the other 2 forces, mu02 and mu03, are 0 in the first 3 years, and the force of transition from state 0 to state 1 is positive. It's 0.01. So for the first 3 years, only the first force operates. And again, here's the model. So state 1 is getting fired. So the only thing during the first 3 years that is a possibility other than continue working at NED is getting fired. So here we'll look at it again. What is the probability of remaining in state 0? Well, it's 3, it would be denoted by 3px00, where x is his age. We could actually ignore that and just write this as 3p00. And because the only force out is that force from leading from state 0 to state 1, which is 0.01, this is basically a standard constant force of mortality model. And the property of remaining alive, if the force of mortality is 1%, the property of remaining alive is e to the minus 3 times 0.01. Because every one of those 3 years, the probability of leaving state 0 is e to the minus 0.01, and then you just multiply it out over 3 years, and you get e to the minus 3 times 0.01. And that's equal to e to the minus 0.03. But it's different once you reach the age x plus 3. So now we kind of need an indicator of where we are in time. So age x plus 3. Over the next year, what is the probability of remaining in state 0? Well, it's e to the minus the sum of all the forces taking him out of state 0, multiplied by the number of years, which is 1 in this case, so really don't need to indicate multiplying by 1. and that's e to the minus 0.21, because it's 0.01 plus 0.12 plus 0.08, so that's 0.21. So e to the minus 0.21. Therefore, the probability of remaining in state 0 over 4 years is the product of the two probabilities. First, remain in state 0 for 3 years, and then remain in state 0 in the 4th year. So it's e to the minus 0.03 times e to the minus 0.21, and that's e to the minus 0.24. And now we calculate it to be approximately 0.7866279, and that's answer C. Please remember, this is computed material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.